Hi everyone. For my final project, I wanted to focus on something close to home. I live in Philadelphia and our drinking water comes directly from the Delaware River. So today I'm going to show how something global like phosphate mining or fertilizer use can actually impact the water system right here in my own backyard by affecting the carbon, nitrogen, and phosphorus cycles. To start, we're looking at where all of this begins, the industrial side. Phosphorus naturally exists in sedimentary rock, but the key thing is that humans are now extracting it at really high rates. What's important here is that this process isn't isolated. Producing fertilizer, especially when we're also fixing nitrogen through processes like Haber-Bosch, takes a huge amount of energy. And that creates a direct link to the carbon cycle because it releases a lot of CO2. So basically, even though we're focusing on phosphorus and nitrogen, there's always a carbon cost attached. These nutrients don't just appear, they're produced through energy intensive processes, and that ties local agriculture to global climate change. So this slide shows my full system diagram. It's kind of the big picture of everything working together. So I broke it down into three main parts: the industrial system on the left, the land system in the middle, and then the river and human system on the right. To read it, arrows mean a positive relationship, so if one thing increases, the other does too. And the lines with the circles show negative relationships, where one increases and the other decreases. The goal here is to show how one action, like mining phosphorus, can create this chain reaction across multiple systems and cycles. So here I'm zooming in on the first major step, when fertilizer is actually applied to land. As fertilizer use increases, we see increases in both soil phosphorus and soil nitrogen. That's a positive coupling, and it leads to more crop growth and more vegetation. So at first, this does look like it's a good thing. It supports agriculture. But at the same time, this system is still connected to the carbon cycle because producing that fertilizer required energy and released CO2. So even though this step is local, just adding nutrients to soil, it's already tied to global impacts. Next, we move from land into the river system. When it rains, runoff carries those excess nutrients, nitrogen and phosphorus, into the Delaware River. This is what connects agriculture directly to our water supply. One really important relationship here is negative. As nutrient levels in the river go up, drinking water quality goes down. And this has real impacts. It means that water treatment plants in Philadelphia have to work harder, using more energy and resources. So this isn't just an environmental issue, it's a social and economic issue as well. All right, so this is where we see one of the most serious ecological impacts: eutrophication, or what's often called a dead zone. These extra nutrients cause algal blooms, which grow really quickly, but the problem isn't the algae, it's what happens after. When the algae die, bacteria break them down, and that decomposition process uses up all the oxygen in the water, creating a negative coupling with dissolved oxygen. As oxygen levels drop, fish and other aquatic life can't survive. So, what started as excess nutrients ends up causing a collapse in parts of the ecosystem. So, this slide shows why the system isn't just a straight line, it actually loops back into itself. So when the decomposition happens, bacteria releases CO2 into the atmosphere. So now we've come full circle back to the carbon cycle. And that means adding nutrients to the river doesn't just affect water quality, it can also contribute to atmospheric carbon levels. So a local issue, like runoff in the Delaware River, is actually connected to a global climate process. It creates this huge feedback loop where human activity reinforces environmental change. So, to wrap up, even though the system can look overwhelming, it also shows us where we can step in and make changes. For example, nature based solutions like riparian buffers can help absorb nutrients before they reach the river. And in Philadelphia, programs like Green City, Clean Waters are already working to reduce runoff by adding green infrastructure like rain gardens and green roofs. So overall, this project shows that protecting the Delaware River isn't just about improving local water quality. It's also a part of a much bigger effort to reduce the impact of human activity on global cycles. By managing nutrients more carefully, we can help break this feedback loop and reduce both environmental and climate impacts. Thank you.